lesson, we have learned about trigonometric identities, and law of triangle in trigonometry. Here in this lesson, we will be learning about trigonometric function. As you know, there are several trigonometric functions, such as sine function, cosine function, tangent function, secant function, cosecant function, and cotangent function. And in this lesson, we will be learning about how to graph some of trigonometric functions. Well, in this lesson, we will be learning the basic one, such as sine function, cosine function, and tangent. Okay, let's start with the first one, sine function. Let's just say that I have a sine function y equals sine x. Now to sketch the graph of y equals sine x, first locate the key points where y equals to 0, -1, and 1, which can be obtained by substituting x with 0, pi over 2, pi, 3 pi over 2, and 2 pi as shown in this table. Okay, then connect the points on the graph where x-axis represent the angle and y-axis represent the sine value. Okay, by doing so, we will get a smooth curve like this that extends in both directions, okay, beyond these 5 points. Okay, as you can see, from x equals to 0 and x equals to 2 pi is called the period of the curve. Okay, so period is the amount of curve or wave in one interval. Okay, the second one is cosine function. Let's just say I have a cosine function where y equals cosine x. Okay, we will draw the graph of cosine function the same way like we did with the sine function. So we use x equals to 0, pi over 2, pi, and 3 pi over 2, and 2 pi. And by doing so, we get the y value of 1, 0, and -1. Okay, and we also plot the points on the graph where x-axis represent the angle and y-axis represent the cosine value, and we get the graph of cosine value. Okay, like this one. Also the same like in the sine function, the interval between 0 and 2 pi is called 1 period. So this is a single cycle. This is the graph of cosine function. If you want to have a more detailed curve, you could add other points or other values like this one, but it requires like calculating device to get that. Okay. From the graph of sine and cosine function, there are some properties of sine and cosine function. First, the domain is set of real numbers. Domain is the x value. Second, the range is a set of y values such that y is in between -1 and 1. So from the point number 2, we get the maximum value for sine and cosine functions is 1, and the minimum value is -1. 4, the graph is a smooth curve. 5, its function cycles through all the values of the range over an x interval of 2 pi. 6, the cycle repeats itself indefinitely in both direction of the x-axis to x positive and x negative. Okay, now let's see the sine function and the cosine function in a more general form. Y equal a sine bx plus minus c plus minus d, and y equal a cosine bx plus minus c and plus minus d. What are these letters represent? A is for amplitude, that shows maximum and minimum value. B is for period, that shows the numbers of waves or cycles formed in one interval. C is for horizontal shift, and D is for vertical shift. Here, I want to show you how amplitude affects the graph of sine. This is the graph of sine with amplitude of 2, 1, and 1/2. As you can see, the difference between this graph is only its maximum and its minimum value. So the form of the graph remains the same. Here, I want to show you how period affects the graph of sine. Okay, as you can see, for y equal sine 2x, there are two waves or cycles within one interval of 2 pi, the blue one. While the dotted line, while y equal sine x, there is only one cycle or wave within the interval of 2 pi. This is the graph of cosine function with different amplitude, like the one that we saw in a sine function. So the amplitude only affect the maximum and the minimum value of the function, and not the form of a function or the curve of the function. As you can see, the red one, the amplitude is 3, the black one is 1, and the blue one is 1/2. This is the graph of cosine function with different period. The red one for the period equal to 1. The green one is for the period equals to 2. So as you can see, for y equals 2x, there are two waves or curves within the interval of 2 pi. And this is how the graph of sine function and also cosine function shifted horizontally and vertically. Okay, now there are key steps in graphing sine and cosine function. The first one is find the new period, 2 pi over b. The second one, find the new beginning, bx minus c equals to 0. 3. Find the new end, bx minus c equals 2 pi. 4. Divide the new period into 4 equal parts to create new interval for the x values in key points where y equals 0, 1, and -1. 5. Adjust y values of the key points by applying amplitude and the vertical shift. Okay, now let's see some of the examples on how to draw the graph of this function.